You're in the final moments of a match, your aim is perfectly lined up, and suddenly, your crosshairs just slide off target. It's one of the most aggravating feelings in modern gaming. Millions of players recognize this loss of control as the specific hardware failure that has defined a generation of handheld gaming. To understand why this happens, look at how a standard analog stick actually works. When you push the stick forward, internal plastic components physically slide against each other to register that directional movement. As they grind, friction shaves microscopic layers of plastic off the mechanisms, creating a fine dust. This dust falls into the casing and intercepts the movement sensors. The controller gets confused by the debris, sending phantom inputs even when your thumb isn't touching the stick. The mechanical friction required to operate the controller is the exact thing slowly destroying it from the inside out. But recently, engineers have mapped out a way to bypass this problem entirely. Buried in the archives of the United States Patent Office is a recent filing from Nintendo. This document replaces standard mechanical friction with a chemical solution, abandoning traditional plastics for a specialized fluid. Patent US 2023-0280-849A1 proposes taking the central shaft of the analog stick and submerging its base inside a sealed container of liquid. The engineers specify the use of a material called magnetorheological fluid, or MRF. Looking closely at this visualization, MRF is a liquid filled with microscopic magnetic particles. While normally flowing freely, the moment it's exposed to a magnetic field, those floating particles instantly align and solidify into rigid structures. To trigger this reaction, the designers wrapped an electromagnetic coil around the fluid chamber. Send a tiny electrical current through that coil, and you generate a magnetic field. Because the console's software controls that current, it can precisely dial the intensity of the magnetic field up or down. As the field strengthens, the fluid thickens, creating an immediate variable resistance against the player's thumb. There are no springs to wear out, and no plastic rubbing against plastic. The stick pushes against a liquid barrier, delivering all the necessary tension without generating the debris that leads to drift. While this design eliminates drift, the primary objective of the patent is to let game code physically push back against the player's hands. The patent text distinguishes between two states: a first viscosity, where the stick moves freely, and a second viscosity, where the fluid becomes so thick it creates heavy, unyielding resistance. This top-down view illustrates how the software can use that second viscosity to build invisible physical walls. The stick moves easily in the green zone, but hits a rigid barrier in the red zone. The engineers note how this adapts to the environment. Drive a vehicle into thick mud, and the fluid instantly hardens, making the joystick heavy and sluggish. They even suggest mapping the fluid's thickness to character health. Take heavy damage, and your controller physically stiffens, requiring more force to move a wounded character. Players physically wrestle with the game's physics through the joystick, turning tactile resistance into a new stream of gameplay information. For over 40 years, our primary window into digital spaces has been dictated by the exact same static mechanical friction. From the early 3D era onward, every major hardware revision has refined a standard set decades ago, relying on plastic parts grinding against each other. This technology allows the joystick to adapt to the software in real time, translating digital environments into a physical experience.